All right, so let's look at how we can use our chemical equations to do some chemical analysis, so some actual applications. So now that we've got our stoichiometry ready to go and you understand all stoichiometric concepts, we can look at some applications. We look at two different ones, and they all fall under the idea of quantitative analysis, essentially. But the basic idea here is you have some kind of unknown that you want to determine. So you want to determine how much of some substance is present in an unknown amount, or maybe there's some impurity in a substance that you want to determine. And you can determine that then from your mole ratios or your reaction equations. And specifically, one of the examples that we will look at is something called gravimetric analysis, right, where we use a precipitate that forms, where it has a known composition, and where we can then determine its molar mass, or not its molar mass, but its number of moles, and then we can work backwards to determine something about a compound in an original sample. So the basic idea in these analyses are that you have two mixtures. So a mixture A and B, but in principle you have something containing one set of ions, so sodium plus and sulfate SO4 2 minus, and the other one, say, barium chloride, so Ba2 plus and Cl2 minus, or Cl minus. All right. And then as you start adding the barium chloride solution to the sodium sulfate solution, then you will see a white precipitate starting to form. And this white precipitate is the barium sulfate, right? And barium sulfate, the precipitate, is something that you should be able to filter and weigh off. And then from that, you can then determine something from the original amount of sodium sulfate, right? Because there is sulfate in this final compound that you extract here. So you know how much barium sulfate you collect here at the end, so you can work all the way backwards and connect it to how much sulfate was then present in the original sample, okay, or in the original solution. And that can give you information about whatever you dissolved initially in this beaker at the way beginning. So you don't necessarily need to know anything, right? So this is a big unknown. Right? So this is, you don't know anything about this, but you do know something here, right? You're measuring a mass there. So you can determine something about that sulfate and you can work your way backwards. All right, and that's exactly the question that we're going to look at. So we're told sodium sulfate occurs naturally as some sort of mineral. To analyze an impure mineral sample, so that's an important word, we'll look at it just now, for the quantity of sodium sulfate. The sample is crushed, then dissolved in water to form a solution of sodium sulfate. Next, the aqueous solution is treated with aqueous barium chloride to give barium sulfate, according to this reaction equation. Suppose we have a certain amount of the sample containing the mineral produces so much solid of barium sulfate. What is the mass percent of sodium sulfate in the sample? All right, so that's a lot of words. Let's try and draw a strategy map, or just let's draw firstly, what do we have? So we're told initially to analyze an impure mineral sample of the quantity for the quantity of sodium sulfate. What that means is, it means we have a mineral. Actually, let me draw it just somewhere else. We have a mineral, right? Like a mineral ore. So it's not a pure sample of sodium sulfate. We have like a block, or like a rock. That's actually a better thing. We have a rock. And some part of that rock, so like this section here, not necessarily a section, but little bits and pieces. That's maybe a better way of visualizing it. So we have a rock and little bits of it, all right? So there are little bits of it that are sodium sulfate. That's what that section means. So we have an impure mineral sample. So we have a mineral sample that is impure, so it contains other stuff for that also contains the sodium sulfate. So we have sodium sulfate and some other stuff. Then this sample is crushed, so now we make it fine. And then we dissolve it in water, which then forms a solution of sodium sulfate. All right, so like we had at top here, we form a solution of sodium sulfate. So that's our starting point. Then we add aqueous barium chloride. So let's draw that for ourselves. So we have a solution of sodium sulfate. All right, so we'll probably just do it like this, SO4. This is, of course, aqueous. And to this, we add a solution of barium chloride, also aqueous, AQ. Okay. And what then happens? It gives solid barium sulfate and sodium chloride, clear sodium chloride solution. You see? It's like this is what happens here. It's exactly this chemical equation. So we say we add this one to this one, and this will cause us to have a solution of sodium chloride. So of course, I mean, it's technically ions in solution, but you can write it however you would like. And what do we have? The barium sulfate, so let's give it a different color, let's make it red, will precipitate out. So it will form a little precipitate here at the bottom. That's what's going to happen. And it's going to form that white powder that we saw in the images above. So we have taken our mineral, so this thing over here, we crushed it, right? We put it into solution. Then we took some barium chloride, we started adding it. That then caused some barium sulfate to precipitate out. Right, barium sulfate solid to form. Okay, now finally, let's look at what the numbers that we're given. Okay, so we're told information about the sample. We're told we have 0.498 gram, let's call it sample. Remember, that's the mass of the impure sample. Okay, that's important. It's not the mass of the sodium sulfate, it's the mass of that entire rock that we crushed. Okay. And then we're also asked, or we're also given the mass of this solid barium sulfate. So this mass here, we're told the mass of the barium sulfate that forms, that we weigh out, is equal to 0.541 gram. Okay. Cool. So I've just drawn now what we're actually told. Now we can look at the question. That's technically my version of a thought whatever map. I would like to call it a thought process diagram, but anyway. What is the mass percent of sodium sulfate in the sample? So now we finally get to the question. The question is, what is the percentage? So the question here is, what percent does the sodium sulfate, so what is the percentage of the dots in that rock? What does that make up? So you see why it's important to notice what the sample's mass is, the impure sample's mass is. So we need to determine what the mass is of the blue dots in the sample, and then we can divide it by the total sample mass and multiply it by 100. That's where we want to get up or end up with. So we want to get to a point where we write something to say mass percent sodium sulfate is equal to mass of sodium sulfate divided by the sample mass multiplied by 100. Okay. So the question is, how do we get the mass of sodium sulfate? Well, we have some information here about the barium sulfate. So we have something about this, and we have a chemical equation. So we, like I said, we can work backwards. We can work from the barium sulfate information, we can work backwards to the sodium sulfate. All right, you notice how that can work. Because we have a mass, so we can work to moles, and then we can use our chemical reaction equation to connect the number of moles to each other, and then we can work back to mass. Okay, so that's a good way to look at it. Cool. So let's go ahead and do that. So from the mass of the barium sulfate, let's get the number of mole of barium sulfate. So you're going to get that by dividing the mass by the molar mass, or in other words, doing the following. Gram barium sulfate multiplied by 1 mole. 1 mole of barium sulfate weighs 233.4 grams. All right, so that's the same as dividing by the molar mass. The molar mass of barium sulfate is 233.4 gram per mole. All right, that's going to give you a value of 2.31, etc., times 10 to the negative 3 mole barium sulfate. Now, if we look at our chemical reaction, you see it's a 1-to-1. So that means the number of mole of sodium sulfate. So, I mean, you can immediately write it down because it's 1-to-1, right? So you don't have to technically do any manipulations. But for completeness, I mean, you can go and write 1-to-1. Then 2.3, 2x. Do your multiplication, write down the units. But this is what you're going to get eventually. 2.31 times 10 to the negative 3 mole barium sulfate multiplied with 1 mole of sodium sulfate per 1 mole of barium sulfate. All right, from the reaction equation, like I said, it's 1-to-1. So that's a divide sign. So that's how you can interpret that. So that means it's the same. 2.31 times 10 to the negative 3 mole. What's this again? Sodium sulfate, SO4. Okay. So now we know how many moles of sodium sulfate there is. So what do we want eventually? We want to know what the mass is. So that we can say mass sodium sulfate divided by mass of the sample multiplied by 100. So in other words, therefore, mass sodium sulfate. How do we get the mass? We multiply by the molar mass. Cool. So 2.31 minus 3 mole and the molar mass is 142.0 grams sodium sulfate in 1 mole of sodium sulfate. That then gives us a value of 0.39, sorry, 329, etc. gram sodium sulfate. So therefore, mass percent, sodium sulfate in sample, in sample. My pen is running out of power, so I need to finish. All right, is equal to 0.329, etc. gram divided by 0.498 gram sample. So this is sample, right? Sample mass. This is the sodium sulfate mass multiplied by 100%. That then gives you 66.1% sodium sulfate. Okay. And that's how you solve it. That's also the concept of mass percentage, right? So it's the mass of whatever you're looking at divided by the total mass of the sample multiplied by 100 gives you 66%. So this will be, this is a typical example of gravimetric analysis. The most important part for you is to figure out where what goes. So like this initial part here, I think of how to draw that. After that, it's relatively straightforward. In the next videos, we'll look at some other ways of how to do quantitative analysis. All right. Thank you for watching.